Rational expressions are basically fractions with variables in them. So before we actually look at a rational expression, let's take a look at a regular fraction that we know how to simplify. This guy, 15 over 24, we would normally simplify this by maybe canceling or reducing the top and the bottom. And in fact, we could say that you can simplify a rational expression by canceling. But let's look at a kind of a new way of looking at this. We're going to say, what if we could break this 15 up into its own unique factors? Like, for instance, 15 is 3 times 5. And then let's try breaking 24 up into its own unique factors. 24 could be written as 3 times 8, and we could even break it down further. But the thing that I want you to notice here that's really interesting is that we can cancel, if we break this up into 3 times 5 and 3 times 8, then we've got a common factor in the numerator and the denominator of 3. So I'm going to go ahead and just cancel just those guys, and of course we're left with 1 and 1, which is essentially just leaves us with 5 over 8. 5/8 is the final result there. And we can do the same thing with rational expressions. And in fact, this is the concept we're going to use. We're going to say you can simplify rational expressions by canceling common factors in the numerator and denominator. In other words, here the 3 was a common factor in the numerator and in the denominator. And the reason why we call them factors is because things that are multiplied together, like 3 and 5, are considered factors of 15. And things that are multiplied together, like 3 and 8, are considered factors, in this case of 24. So let's apply this simple concept to something that looks a little more complicated. This guy's a rational expression. Unfortunately, right now, there's no way we can cancel stuff in the top and the bottom. It's kind of a rule. Although we say we can and we want to cancel common factors in the numerator and the denominator, you cannot cancel terms in the numerator and the denominator. So in other words, canceling this 16 and this 8, strictly illegal, because they're being added or subtracted. So one thing that we could do, though, is maybe if we can factor the top and the bottom, then we could find factors that are in common, and if they are, then we can cancel. So 9x squared minus 16, I'm hopeful you recall, that's a pattern called difference of squares. And when we go to factor, we should get something like 3x minus 4 times 3x plus 4. That's something that if you don't remember, go ahead and Google difference of squares. That's something that you should practice. Another thing that we've looked at before is factoring using this x factor method. Negative 8 times 3 gets us negative 24. Negative 2 goes down below. And our goal is going to be to find two numbers that multiply together to get us negative 24 and add up to get negative 2. We do that by making a list of factor pairs of 24. So 1 comma 24, 2 comma 12, 3 comma 8. Unfortunately, none of these are going to add up to 2 no matter how we change the signs around. But there is one more, 4 comma 6, and that guy looks pretty promising. So I'm going to put 4 and 6 here. We'll make the 6 a negative. Negative 6 plus 4 is negative 2. Negative 6 times 4 is negative 24. And then don't forget we have to divide by this 3. So I'm going to go ahead and divide by 3, divide by 3, and then we reduce if at all possible. So we reduce. And by the way, all of this stuff that I'm doing is not necessarily a part of canceling common factors. It's just that you must factor whatever you have in order to be able to cancel. So all I'm doing here is reviewing some older material. In a minute we'll get back to canceling common factors. We'll see it right here. Anyways, let's finish this off. So 4/3 cannot be simplified, so we leave it. Negative 6 over 3 is the same as negative 2 over 1. And so then we can rewrite this as 3x plus 4 yay, over x minus 2, or I'm sorry, times x minus 2. These guys, if we multiply them together, we get this. So I'm just going to rewrite them here as 3x plus 4 and x minus 2. And since the numerator is all multiplied and the denominator is all multiplied together, then 3x plus 4 and 3x plus 4 are considered common factors. So we'll go ahead and cancel this with this, and that leaves us with 1 up there, and it leaves us with a 1 down there. And finally, we can rewrite in a much simpler form 3x minus 4 over x minus 2. Now again, it might be tempting to go ahead and try to cancel these x's, right? But you cannot. They're part of a term. 3x is being added to negative 4 and x is being added to negative 2. So we cannot just cancel those x's. And it might be tempting to cancel this 4 with this 2, but we cannot, because this 4 is a term in this polynomial 3x plus negative 4, and we can't cancel the 2 because it's a term in the polynomial x plus negative 2. So the best we can do is this. And the good news is our best is good enough. And in the case of simplifying rational expressions, we've done what we wanted to do. We canceled common factors.